Okay, hi everyone. Very good day to everyone. So today we're going to look into the exit pass for 10.2a, where we talk about the graphs of trigonometric functions. Right. So I think this subtopic is actually a very big topic because there's a lot of facts to memorize. But I think the most important thing would be from the ABC of the equations, right? From the ABC of the sine, cosine, and tangent functions, we're able to relate them to the amplitude, the period, and the middle line or the vertical shift of the trigonometric graphs. All right. So this is really like to from ABC get the properties of the trig graphs, or from these properties of the trig graphs to obtain back our ABC. Alright, so we also from there we can determine our maximum minimum, and we can also sketch the graphs of sine, cosine, and tangent. So without further ado, let's jump into the exit passes question 1. So for each graph, state the amplitude and period, hence find the value of A, B, and C. So alright, so we need to look for the amplitude, right? And we need to look for the period. Okay, so what is the amplitude? For this one, the graph is given to us, so we can just look into the amplitude, where it's just the distance between the middle line and the maximum, or it can be from the middle line to the minimum. So what is the amplitude? The amplitude is going to be 3 units. And what about the period? The period will be the angle needed to complete one wave. So the angle needed to complete one wave would be actually 180 degrees. So this period is 180 degrees. So without further ado, let's do our ABC. Now A would be 3. We'll follow the amplitude, and this is a positive sine graph, so it will be a positive 3. C is going to be 2. From the middle line is 2, so C is going to be 2. Now to find B, we're going to make use of the formula period is equals to 360 over B. For a sine graph, it is 360 over B. So the period would be 180 equals to 360 over B. Solving for B, B will be equals to 2. So the value of B is 2. So the whole function would look something like this. Y equals to 3 sine 2x plus 2. Okay, so 3 sine 2x plus 2. So let me write them down somewhere. Maybe this would be y equals to 3 sine 2x plus 2. Okay, so this is question 1a. For question 1b, we are looking at this over here. This is a cosine graph. Okay, so let's take a look at our amplitude. Right, amplitude and our period. Now, sadly, for amplitude, we don't have the middle line to do this. But actually, can we get the middle line? Actually, we can. Right, so what's in between 4 and negative 2? So that's one way to look at it. Now, for amplitude also, it can be this full length divided by two parts, because amplitude is just from the middle line to the top. So when we get the difference between the maximum and minimum, we just need to half it to get our amplitude. So let's do that, shall we? So amplitude, we have a 4 minus a negative 2, the difference, divided by 2. So this gives me, this gives me an answer of 3. And from the period is actually the length, amount of degree for one wave, or the amount of time for one wave. And actually the period is actually the size of one wave, right? So this wave ranges from 0 to 6 pi over 8, if you notice, right? So over here the period would be 6 pi over 8. If you want to simplify, it can be a 3 pi over 4 radians. Right? So with that, find the value of ABC. So A is going to be equals to 3, the amplitude is 3, and this is a positive graph, so A is 3. Now for C, right, we can make use of the maximum plus minimum divided by 2. So what's the maximum and the minimum? The maximum is 4 plus a negative 2. So this would give me 1, the value of 1. Okay, and last but not least, our period. So our period, right, would be equals to 2 pi, which is 360 over B. So the period is 3 pi over 4, which is equals to 2 pi over B. We can actually cancel the B, and cancel the pi. So B will actually be 8 over 3. So the function is going to look like this. So y is equals to A cos 8x over 3 plus c plus 1. Okay, so the function is going to look like this. Okay, moving on to question 2. So question 2 is rather easy. We just need to find the maximum minimum values of fx and the corresponding values of x in the interval of 0 to 360. So first one will be in degree. Now, so to find the maximum minimum is very easy. So the maximum is actually, we start off with the cosine, the middle line 3, the amplitude is positive, the amplitude is 2, so we're going to go up 2 steps. So it means it's going to be 3 plus 2, so the maximum is going to be 5. Okay, so when is it going to be maximum? It is when this sine x, right? When this whole thing is equals to 5. So technically speaking, right, you can solve the whole thing like when 2 sine x plus 3 equals to 5. So 2 sine x is equals to 2. Sine x is equals to 1. So x is equals to 90 degrees. Okay, but the thing is, right, so you can think of it as you just look at the angle, just think like in the normal sine graph, when is it going to be maximum? The maximum is when it is going to be 90 degrees. So you can like straight away state like when x equals to 90 degrees. Okay, so there's two ways. One, you can solve the full thing manually. The other way is to think when is the function going to be maximum. Okay, then the same way, the minimum value of the graph would be from the middle line 3, I'm going to minus 2 from the amplitude, so it's going to be 1. So the same thing, you can also do 2 sine x plus 3 equals to 1. So 2 sine x is equals to negative 2. Sine x is equals to negative 1. Then when you solve for x, right, the calculator will give you a value of 270. Okay, so you can do this, or you can think from the graph, the normal sine graph, the minimum is over here when it is going to be 270 degrees. So this is when x equals to 270. Okay, pretty easy, right? Next, okay, so here maximum is going to be middle line is 4. I'm going to add 4 steps, so it's going to be 8. Okay, minimum is going to be middle line 4. I'm going to minus 4 from the amplitude. It's going to be 0. So this graph is going to be like between 0 and 8. Now, so when is it maximum? When is it minimum? This is a cos x graph, right? The x is just 1x, so it's easy to think in terms of 1 revolution. Then the next thing is this is a negative cos graph. So if you want to think from the graph, if you don't want to solve manually and think directly from the graph, the negative cos x is going to be something like this. Okay, the negative cos x is going to be something like this. So where is it minimum? The minimum is going to be at these 2 points over here. So what are the angles of these 2 points? It's going to be 0 degrees, 360 degrees. When is it going to be maximum? The maximum is going to be here. So the maximum is going to be at 180 degrees. So the maximum is when the angle is 180 degrees. The minimum is when the angle x is 0 and 360 degrees. Right, so it's just like that. Okay, let me remove this. Okay, so you can see roughly how it is like. Okay, so yeah. Okay, let me delete this and delete this. Okay, next one. In the interval between 0 to 2 pi. Okay, so the exercise is going to be the same. The maximum would be the middle line plus amplitude. So c plus a. So it will be 1. The minimum is going to be c minus a. So it will be negative 5. Okay, so it makes perfect sense. This is a cosine graph. So for the cosine graph, let us sketch roughly. It will look something like this. Basic cosine graph. Okay, middle line over here. So where is the maximum? The maximum is over here. This is the normal cosine graph, so it will be 0 and 360 over here. The minimum is over here, so this is 180 degrees. So this would be when x is equals to 0 degrees, or when x is equals to 360 degrees. Okay, next, this is 3 minus 2 cos. Oh, wait. We need to be in radian mode. So, sorry. So this is going to be 0 and 2 pi radians. Then 180 degree will be pi radian. Okay, like that. pull this down a little bit. Okay, next, let's take a look at next one. Fx is equals to 3 minus cos 2 cos x. So the maximum would be the middle line 3 plus a 2. So the maximum is 5. The minimum is going to be middle line 3 minus 2. So it's going to be 1. This is a negative cos graph. So visualizing the negative cos graph, something like that, right? So at 0 and 360 degrees, you will get my minimum. And at 180 degrees, I'm going to get my maximum. Okay, so this is when x is equals to pi radian at 180 degrees, or when x is equals to 0 degrees and 360 degrees. So it will be 2, 0 and 2 pi radian. Okay, rather straightforward. Now, what happens if x is not is instead of like 1x, right, is like 2 or 3x. So we can do this actually. So if okay, so let me put a pointer over here. So if the question give example so fx is equals to 3 cos 2x minus 2. Okay, and let's go one fancy one over here. Fx is equals to, let's say 2 cos 3x over 2 minus 2. Very fancy, right? A bit weird, right? Okay, so let's see how this works. So you are also referring to the positive cosine graph. Okay, you're also referring to the positive cosine graph. Okay, it's just that this value, right, we just need to treat this as a subject. So we are going to think the same. This is going to be 0 and 360 degrees. Okay, and the minimum is going to be over here as well. Okay, so what am I going to do is, it is when 2x is equals to 0 and 360. So x is equals to 0 and 180. Okay, for the maximum. Okay, then for the minimum, it is when 2x is equals to 180 and x is equals to 90 degrees, something like that. Okay, so this is how we are going to get the maximum and minimum values. If the angle is not 1x, the angle would be 2x or 3x or some other random arrangement. The next example, right, same thing. Making use of the cosine graph, right? You have the 0 and 360 degrees. So this would be the maximum when, right, 3x over 2 is equals to 0 and 360. And then x is equals to 0 and 120 times 240 degrees. That. Okay? And the minimum when 3x over 2 is equals to 180. So x would be equals to 60 times 220 degrees. Okay? So things like that. If the angle is not 1x, then you have to do a little bit of adjustment. So it's something like solving for the solving for the angle when you're doing the ASTC, and then you need to do some readjustments at the end. Okay, without further ado, let's head on to number 3, the more important part, which is to sketch the graph of this function for the given interval. So we have this very set interval over here. If you want, you can actually rearrange to actually see the full information. Okay, so it's 3 sine x over 3 plus 2. Okay, so in general, right, when we want to sketch the graph, we follow these few steps. We look at the shape of the graph first. Okay, and the shape of the graph, right, is determined by whether is it a sine graph, cosine graph, or a tangent graph. And we see whether is it a positive or a negative graph. And we get the shape out. Okay, and number 2, we determine how many waves to draw. Okay, how many waves to draw, how many cycles to draw. Okay, and thirdly, we label the y. After labeling the y, we label the x. Okay, so this is usually the steps that I tend to take when I'm doing this. Okay, so this is so first one, let's take a look at the shape. This is a negative sine graph. Okay, this is negative sine graph, and means that it will be something like this. It will be in this shape, right? The positive sine graph is like this. The negative sine graph will be like that, flipped on the vertically. Okay, then let's take a look at how many waves do we need. Okay, so from here, the b is equals to 1 over 3, correct? B is equals to 1 over 3. So with this, right, I'm going to get a period of, so my period is going to be the original sine period 360 divided by 1 over 3. So this is going to be 1080. Okay, so the period is 1080. But I'm sketching for 540. So this means what? How many waves do I need? This signals to me that I need to draw half of the wave, because this is half of one period. Okay, 540 degrees is half of 180 degrees. So let's start to draw the graph. So this is a negative sine graph, and I only need a half of the wave. So I just need to be like this. Okay. Okay. Or maybe if you want, right, you can use a dotted line to guide you, like the dotted middle line to guide you. Okay. So let's say if you have middle line, okay, then you have something like this. Okay, the full wave is going to be like this all the way to 180, but we're just going to draw half a wave. Okay, so let's label the y first. Okay, you can draw in the axis for y. Now you can think why I don't draw the axis first, because right, if I draw the axis first, it will be, it will be a bit troublesome to like label here and there, right? So drawing the axis after everything would be actually a good strategy. So where's the middle line? The middle line is 2. The maximum is 5. The minimum is going to be 2 minus 3. So this would be negative 1 over here. Okay, this is negative 1 over here. So then where is our x-axis? Then you can label our x-axis somewhere close to negative 1, somewhere over here. Right? Okay, if you're not happy with this x-axis, maybe you can lower a bit to like roughly 1/3. Then we label our axis. Okay, so let's label our axis. So we have this to label. Oh, sorry. Okay, so we have this to label. Okay, over here, right? So this is 540. This is 270. Like this, half of 540 is 270. Okay, and this is our x. So our graph would just be like that, half of a wave. Okay, so this is our graph for A. Now for B, we have 2 cos 3x plus 4, 0x, between 0 to x to 360 degrees. Okay, sure. So same thing, the first thing, okay, remember the first thing is the shape, right? So this is a positive cosine graph, so it's going to be like this, positive cosine graph. Okay, the next one is how many waves do we draw? Okay, so let's take a look at the period first. So from here, my b is equals to 3, and because my b is equals to 3, I can calculate my period. So my period is going to be equals to 360 over 3. So my period is going to be 120 degrees. So this signals to me that if my period is 120 degrees, I need to draw 360, right? So it means I need to draw 3 waves. I need to draw 3 times of 120. Now another way to see this is here, right? This 3x, right, is the in the original 360 degrees. I need 3 waves. So it's actually consistent. Okay, sorry, micro-Huawei. Okay, 3 waves. It's actually consistent to like whatever that we need to draw over here. Okay, that whatever that we calculate over here. So this 3 means this way. Okay, so let's draw in our waves. So we need 3 waves, right? So we need the help of the middle line. Okay, so let's get our middle line ready. Okay, then 3 waves, 3 positive waves. So I'm going to start like this. Okay, so 1, 2, 3, 4. 1, 2, 3, 4. One more. 1, 2, 3, 4. Okay, cool. Interesting, so okay, I know you have like, okay, maybe let me centralize this a bit. Okay, I can do this here lah, but you, okay, you just take care lah. So then let's label the y, right? Let's label our y. So the middle line is 4. We plus 2, we're going to get 6, minus 2, we're going to get 2. So where would our 0 be? Our 0 be somewhere below. Our 0 be somewhere over here. Right, so this would be where our 0 be. Okay, so we label the y, we label the x. Okay, so don't worry too much. Let's do some labeling over here. So this is okay, here's something here. Okay, so we label like maybe like where is one complete wave, and we maybe label the halves. Okay, and then I think like that is enough. We don't need to label the quarters. Unless like it's 2x, right? Then the quarters will be more important lah. But I think for now, never mind. This is a bit ugly, so let me like get a little bit more like here. Like that. Okay, can lah. Huh? Okay, so the full wave is 360. So means this is going to be 240. This is going to be 120. Half of this is 60. In between this is 80. In between that is 207. In between that is 300. Yeah, 300. Yeah, like that. Okay, so it looks a bit more consistent. So you see, 3 waves. The amplitude is 2. Middle line is 4. Okay, just nice. Okay, so if you want, you can like relabel this thing y equals to 2 cos 3x plus 4. We really draw in this range 0 to 360. Okay, so this is A and B. Alright, let's take a look at this one. Okay, this one is hideous. Okay, a warning to you, this is going to be very hideous. Okay, why? Because right, this is going to be B is equals to 4, right? And for a tangent graph, right, this is a positive tangent graph. Okay, the period, right, is going to be equals to 2 pi over 4. So what does 2 pi over 4 period, right, is actually pi over 4. Pi over 4. So pi over 4, because like for a tangent, right, the original period is pi. So 1 pi over 4. This means that it's going to be 90 degrees. Okay, and 90 degrees and 360 degrees, right? How many waves are we going to draw? This means we are going to draw pi over 4 is 45 degrees. So we need to draw 8 waves. Okay, because right, this is 8 times of the 1 full period. Holy moly. Okay, so let's get going. Okay, there's no plus C over here, so I think very confidently I can just add this over here then. 8 waves. Okay, so I think for tangent, right, the approach will be a little bit different. For tangent, right, if there's a shift, then you just draw the shift without drawing the axis first. But for tangent, right, I'm going to go with the asymptote method. Okay, so I'm just going to draw the asymptotes first. Okay, so roughly you need to know where are your asymptotes, yeah? So the asymptote starts from 90 degrees, or like the like the first part of the asymptote, right, is okay. Yeah. So the first part of the asymptote is like a bit closer to the axis, then the remaining is like a 1 full gap away kind of thing. So 1, 2, 3, 4, 5. Okay, I think I need 2 more. Like this. You see, this one, wow, this one really is going to. Okay, 1, 2, 3, 4, 5, 6. I need 2 more waves here. So you see, this one really take a lot of space. Okay, 2 more waves. Holy cow. Okay, 2 more waves. So let me add in 2 more. 1 more and a half there. Can. Okay. Then yeah, so this is going to take a very, very long while. So you just bear with me, okay? So this is my x. Okay, so means okay, so why is the first one like nearer, right? Because the first one is going to be like this. Just like this, going up to infinity. Okay? Then the second one would be like this. Okay? This coming through and go down. Okay? Next one, coming through, go up. Okay? You can draw up or down, up to you. Like depends on your stroke lah, how, yeah. So like this. Okay. Whoa, this is, oh dear. 1, 2, 3, 4, 5, 6, 7. This is number 7. 7.5, right? 7.5 in front. Okay, then complete my number 8 like this. Okay, so this is 2 pi. Okay, this is going to be 2 pi. Holy moly, then we just label one by one lor. So this is pi over 4, pi over 2, 3 pi over 4. Okay, so we go 1 quarter pi by quarter pi lah. Okay, so 3 pi over 2. This one is 3 pi over 2. So this is going to be 3 pi over 4. So this is going to be 1 pi. 5 pi over 4, 6 pi over 4, 3 pi over 2. Then 7 pi over 4, this will be 2 pi. That means how many waves am I drawing? Period is this. So this is 1 quarter, right? Okay, hold on. Okay, I think I made a mistake over here. Okay, let me go back to do this. Okay, sorry about the earlier mistake. Yeah, it's actually 1 period is pi over 4 though. So actually, right, the pi over 4 should be over here, 1 period. Because, right, this is actually 1 full wave, right? So this forms 1 full wave. Or technically, this also forms 1 full wave, right? But because since we start with 0, right, so this forms 1 full wave. Then the second wave would be this, right? Then the third wave would be this. The fourth wave would be this, right? Something like that. Okay, so first wave, then I have pi over 2, 3 pi over 4. Then this is pi. So this is 5 pi over 4, 6 pi over 4 or 3 pi over 2, 7 pi over 4, and my 2 pi at the end. Okay, so I can label it like this then. Okay, so 8 waves, 1/3 tangent for x. There's no maximum minimum of tangent because it goes up to infinity. Okay, but oh, holy crap. Okay, next, question 4. The function is defined by this. Oh, before this, I have a short well, actually it doesn't matter. Okay, so actually there's no issue with this question. Okay, we go on with number 4. So the function f is defined by this. State the amplitude, period, and range of fx. Okay, so we have a range. So what do we mean by range of fx, right? Range of fx means the range of y values. Okay, range of y values. Okay, so so some like function terms for you, the domain, right, is the for x values, the range of x values. Okay, and the word range, right, we normally use for y values. Okay, so yeah, so some info for you, not that's really important now, where I would like repeat for you. Okay, so this one, amplitude. Okay, so we rearrange this one. So 3 cos 2x minus 1. Amplitude. So amplitude is going to be 3. Okay. The period. Okay, so what's the period going to be? The period is going to be original cosine graph 360 divided by b. B is going to be 2. So this, my period is going to be 180 degrees. Okay. So below, sketch the graph of this between 0 and 2. Oh, wait. It's pi. So pi, because they want radian, right? So I'm going to get 2 pi. So this is going to be pi radian. Okay, so sketch the graph of here, indicating clearly the coordinates of maximum, minimum points, and end points. Sure. So, okay, so what are we going to do is, because this is a cosine graph, so let me get this out first. Let me get this wave out first. And then, right, we are actually going to go, okay, the original, okay, because we are drawing for 2 pi, and the period is only like pi, so it means that we need to draw 2 waves. Okay, because 1 wave is pi, 2 wave will fill 2 pi. Okay, so let's get this out. Okay, so I'm getting this out. Then, okay, because I need to draw 2 waves, this is a positive cosine graph. So it means that the graph would look like this. So it will start like this. Right, like this. Like this. Part 2, part 3, part 4. Right, next one. Part 1, part 2, part 3, part 4. Okay, we go like this. Okay, then we label the y. So let's label the y. Okay, our y, right, this is -1. The middle line is -1. So -1 plus 3 is going to be 2. -1 minus 3 is going to be -4. Okay, so where would our x-axis be? Our x-axis will be slightly above here. Okay, would be over here. Okay, can. So we really labeled the positive and negative and so on. So these are our positive and negative points. Okay, so if you find that it doesn't really touch the positive negative, you redraw lor. Like that. Okay, come here, like that, come here. Okay, yeah, so this will be -4. Okay, and if you want to label the x, right? Okay, so the x you can label it like this. You can do the half of this, you can do the half of that, right? You can also do the half of this. Okay, so this would be 360. How 360? Okay, so this is 2 pi. 360 degrees is 2 pi. Half of this is 1 pi. Another half is pi over 2. This would be 3 pi over 2. Okay, I think maybe I would draw nicer lah. Okay, pi over 2 over here, 3 pi over 2 over here, 3 pi over 2. Okay, now last but not least, where is the number of solution for the equation? Okay, so on the same axis, I'm going to draw this graph. So actually this graph, right, if you notice, okay, so gx is equals to x over 30 pi. Alright, if you want to rewrite this, right, it's actually 1 over 30 pi x. So this is actually a linear graph because x is just x, correct? It's a linear graph, and this is your gradient. 1 over 30 pi is your gradient. Okay, so very easy. We just need to find out what are the 2 points of the graph. Okay, so very easy one. So so very quickly we set up our table because a straight line graph we only need, actually any graph we need table lah, but yeah, very easy to put this. Okay, so when x is 0, the gx is going to be 0, y is going to be 0. Okay, and when x is 2 pi, because I want to draw the end, so 1 over 30 times 2 pi will actually give me 1 over 15 actually. Okay, 1 over 15. Okay, so these are my two values that I will use to plot and to draw the graph, because to draw a straight line, technically speaking, we only need 2 points. Okay, something like this. 1, 2, 3. Okay, so let's draw in these 2 points. So my first point is 0, 0. My second point would be 1 over 15, which is actually something over here. Okay, very small. Okay, so my line is going to be something like this until here. Okay, something like this. Okay, so this red color line, right, is actually gx equals to x over 30 pi. Then my blue color line is fx equals to what is this? Okay, -1 plus 3 cos 2x. Okay, so we have two lines over here. Okay, so right, the idea for this is that we are actually trying to look for solutions of the graph between solutions between two equations or two graphs, two functions, and we can use this by means of sketching, and we are not solving for it, we are just looking for the number of solutions. Okay, so based on the intersection between your f and g, how many solutions are there? So we have 1, 2, 3, 4 solutions. Do you see these 4 points of intersection? So these are your 4 solutions. So this one, right, we just need to rearrange to like what we had earlier. So actually this is negative x over pi 30 minus 90 cos 2x. Let me divide by 30. So negative x over 30 pi is equals to 1 minus 3 cos 2x. So this is my original y, this forms my another y, correct? So technically I have this graph, technically, right, I have this graph drawn, and I've also drawn this graph, so it's actually an intersection between these two graphs. Okay, so yeah, which is what we always done in the E-maths and so on. So the answer is there are 4 solutions. We don't need to solve, we just need to state the number of solutions. Okay, between the two graphs. We sketch the graph and then we state the number of solutions. Okay, there are 4 solutions. Okay, I think last but not least, the bonus question. Okay, the functions fx and gx are defined between 0 to 360 degrees. State the amplitude and period for each function. Sure. So for fx is going to be, the amplitude for fx. Okay, wait, so for fx, okay, amplitude. Okay, so the amplitude is going to be 2 cos 3x, right? So 2, the period, okay, period is going to be, okay, the original period divided by 3. So the period is 120 degrees. Okay, then for gx, okay, for gx, right, the amplitude, okay, for the, okay, I will do this in red since, yeah. Okay, so for gx, oh, should I do this? I should do this in purple, yeah, a bit more, because iPhone 14 got purple, so yeah. Okay, so for gx, okay, amplitude is going to be equals to 1, okay, then the period, right, is the original period 360 divided by b. So actually the period is 720. Wow, a bit far. Yeah, it's a bit far. Okay, so on the same axis we are sketching two graphs, these two graphs indicating clearly the coordinates of the maximum and minimum points. Sure. Okay, so find the number of solution, deduce. Okay, so let's take a look at this one over here. Okay, let's sketch the graph now. So the first graph that we are sketching is going to be the cosine graph because it's actually more complicated for this graph. Okay, so let's take a look. Let's get our line up. Okay, so how many waves are we going to draw? Okay, same question. So 120, we are drawing for this. We need to draw 3 waves. Okay. Okay, the other one, right, 720 and 360. So this actually means you're drawing half a wave. Okay, sneaky, Okay, so let's do this. Okay, so let's start over here. Okay, maybe I'll put the Y to start us off nicely first. Okay, so maybe I'll start with these 3 waves. So I'll go with this. There's a lot of cancellations here. Okay, let me go lower. I think lower a bit better. Okay. Okay, so these are my 3 waves. Okay, they look painful, but okay, so let's figure out where the wave are. So my middle line is going to be -1 based on my function, -1. My amplitude is 2, so this will be 1, this will be -3. Okay, I think so far everything looks okay. So where's my x-axis going to be? My x-axis will be somewhere over here. Right, somewhere over here, in between 1 and -1. Okay, my y is going to be over here. So I think it's time to maybe label like where are my points are. So maybe, okay, let's mark the important points. So my maximum, this maximum over here. So these are one wave. This would be my half wave, and the other half wave over here. Right? Okay, like this. Okay, so so in total we have 360 degrees. So when we divide by 3, it's going to be 120, 240, 360. Then half of this is 60, in between is 180, in between is 300. Okay, so we've settled the first one. We've settled this is fx equals to -1 plus 2 cos 3x minus 1. 2 cos 3x minus 1. Okay, so this fx. Next, okay, so next one, right, is actually sine x over 2. So we are drawing half a wave, and actually we just need to, because right, this is an easier graph to draw, so we can draw it later. So actually the amplitude, right, is 1. Correct, the amplitude for this graph is 1. So this means if we start from 0, because the positive sine graph is like this, and we only need half a wave. And this is actually a maximum and 0, correct? There's no shift for this graph. So technically speaking, I just need the 0 and 1 somewhere. Okay, so means I'm going to need this point over here. I will end at this point because half a wave is there, and I'm going to need this 1 over here. Okay, so I'm going to like try to draw like this graph poorly, half a graph poorly. So it's going to be like, wow, it's going to be like this. Or maybe I should start from here. Horizontally downwards to this one. Ooh, okay. Then to 360 degrees. Whoa. Okay, not enough. Cannot overshoot. Cannot exceed 1 first. We have to like reach 1 at the end. Okay, reach 1. Okay, wow. Okay, so this purple color graph, right, is okay, gx equals to sine x over 2. Okay, we cannot hit the maximum too early because the maximum is going to be at 180 degrees over there, right? Okay, so we have our two graphs out, which is a very incredible feat. So hence, find the number of solution for this and that. Okay, so actually this is just rearranging to sine x squared equals to sine x over 2 equals to 2 cos 3x minus 1. So it's the y on the left and the y on the right. So it's the graph on the left equals to graph on the right. So therefore, we have how many solutions? Let's count. 1, 2, 3, 4, 5, 6 solutions. Okay, so technically we have 6 solutions. Okay, this one is the interesting part. So deduce the value of k for which the equation this equals to sine x over 2 plus k has only one solution in the interval 0, x and 360. Justify your answer. Okay, so what does it mean, right, is that okay, because this graph, right, 2 cos 3x minus 1, this graph is a complicated graph, and we actually draw this graph, correct? This k actually means because like based on a sine b x plus c, right, this is the plus c, correct? Means k would be our middle line, or k would be our vertical shift. Okay, k would be our vertical shift. Okay, so let me draw in, right, let's say if k is where should k be to get that one solution, right? It's actually over here. So okay, so let's say if you move it upwards, it's going to look like this, right? If you move it upwards, it's going to look like this, correct? If you move the graph upwards, right, it will look something like this. Okay, so how many solutions are there? One solution, two solutions, correct? So if we move the graph up, it will be like this, plus k. So this is sine x over 2 plus 1, because we move up by 1 unit, correct? So where should we get that one solution? It's actually over here, like here, over here, right? You see, and then come down again over here. Okay, so there's only one intersection over here, and actually what is this unit? Like how many units that we need to shift down? So actually this would be a negative 4, correct? Because we hit here at negative 3, so this is the spacing is 1 unit, the amplitude is 1, right? So it means that from negative 3 we add a 1 down, we are going to minus 1, so it's actually negative 4. Okay, so this means okay, I'm going to remove this because it's going to be messy, so I'll just write down. Okay, so actually k is going to be equals to negative 4. Okay, so how much you need to shift down to get one solution, okay, or one intersection? So k equals to negative 4. Okay, so deduce the values for which the equation has only two solutions. Oh, just now we drew already. We drew the first one over here, right? When there's only two solutions, it is actually over here. Right, over here. One solution, two solution. If it's going to be over here, right, you have like 1, 2, 3, 4, 5, 6 solutions again. Okay, but like what we draw earlier, right, we have two solutions over here. How many units are we shifting out? The k will be actually equals to 1. We add 1 over there. Okay, so the answer is, okay, so k is going to be equals to 1. Okay, justify your answer. Okay, so if we really want to justify our answer, right, okay, k is the vertical shift, and then when okay, y equals to sine x over 2 is shifted down by 4 units, it intersects fx at this point. So x is 180 degrees, y is -3. Okay, so same thing, k is the vertical shift. Okay, so when y equals to sine x over 2 is shifted up by 1 unit. So it's actually explaining what we did just now lor. Okay, so it intersects fx. Okay, so where did it intersect earlier? It intersect at the two earlier points, right? So it will be 0 degree and 1, and 360 degrees and 1. Okay, so there's only one solution, two solutions for this case. Okay, so I think that's all for this video. This is not easy, but yeah, but it's something good that I want to expose to you. Okay, so that's all for this question, and that's all for this exit pass. Okay, bye bye.